to Morpheus Chair special program, Why Do I Need This? So in these programs, what I'm going to try to answer is questions that you people ask in the comment section or in the chat that are very important, and I think that in internet you find how to do it, but not why do you need to do it. So we're going to try to answer those questions. In this video, I'm going to try to answer why do you need classes in ROS with Python. To the workbench. To the workbench. The first thing we're going to do is launch our ROSject that I leave in the video description. And while it loads, just to tell you that all the code will be in this Git that you can download whenever you want. It's called the Why Do I Need, and I leave it also in the description below. So it's loaded already, very fast. Let's close this for a moment. So the first thing we need is a simulation to do this example. So let's start with an empty world. There we are. So we have an empty world, and then we're going to spawn Gurdi. There you go. So we have it here. So this robot is very simple, has basically 6 joints, and it has an IMU inside it, and we're going to use it for the following. So let's say I want this robot to be able to detect that it's upside down, like this, and then moving its legs, return to the upright position like this. Okay, this is the objective of this video. And through that, I'm going to show you why you need classes and when do you need classes for ROS. Yeah, so let's open the IDE. And let me just start the shell for afterwards. Okay, so all the code is inside this Why Do I Need Git, and I have all the examples here. So let's go for the first example, which is IMU behavior. So what I want to do is read the IMU topic. So let's see. Okay, ROS topic, list. Well, a lot. Let's see ROS topic, list, grep, IMU. Yeah, ROS topic, echo -n1. So only see one publication. And there you go. So with this data, I want to be able to know if Gurdi is upside down. So we only need the orientation. If the orientation tells me that it's upside down, then that's my detection. So I'm going to create a Python for that. As you can see, we're not using any main method or something like that, no classes, anything. So here we start. We initialize a ROS node, of course, and then we start a subscriber for this Gurdi IMU data of type IMU, and it has this callback, which we define here. And then we do a ROS by spin so that it stays there forever, and this callback gets called all the time, each time that we get a new message like this one. Yeah? Okay. Then this, what does it do? Essentially, we do 2 things. We detect if it's upside down, and we extract the IMU data. Let's see the IMU data. As you can see, we are getting the orientation, which is this orientation that we have in this message. And then we have to convert it to roll, pitch, and yaw because it's more intuitive than working with quaternions. I'm not able to know if Gurdi is upside down, seeing only the quaternions. Maybe you can do it, I can't. And I suppose a lot of you guys and girls also, you can't do that. So we do this. Essentially what it does is convert the quaternions to roll, pitch, and yaw. And it returns this. This is a method, normal function. And once we have that, we use that data to detect if it's upside down. So let's have a look. How did I get these values? So essentially I executed this once and saw the values in the roll, pitch, and yaw. And based on that, I saw when it was upside down, which values were more or less. And based on that, I got these values. That's it. There's nothing else. So let's execute it. So ROS run example IMU behavior.py. There we go. Let me put this here. Perfect. So you can see that more or less the roll is around -0.6, depends on the orientation, and the pitch is around 0.5, is quite high. So when we turn it upside down, we see that the pitch goes very low, and the absolute value is very high, so it's 3.1 or -3.1. So based on that, we say, okay, so we use one of these to detect that it's upside down. That way, if it goes upright, great. And if it goes upside down, we detect it. Perfect. Fast and easy. Okay. So now we have to do something to trigger a behavior. To that, in ROS means to write in some topic that moves the joints. So in this case, ROS topic list. Let me grep command. And we have to publish in these 6 topics to move each of the 6 joints. So that's the next step. So how do we do it without classes? Here's an example. Exactly the same thing. Now I just removed and I'm only using the roll, because when we go upside down, it changes the pitch and the roll. So indistinctly, it doesn't matter which one I choose. So I'll use only the roll. Yeah. Okay, so how do we do it? So let's go to our beloved get emo data. We have the same exact methods, but here we say, okay, did I detect upside down or didn't I detect upside down? So if you go here, now what we're doing is evaluating if we detect it or not and returning a Boolean. Very easy. And if we detect it, we want to execute the movement flip. If we haven't detected, then the basic stands. And based on that, we execute the movement, which is this huge method here, this huge function. So what we do is we have to initialize the publishers, and we initialize it every time that this callback is called. So you can see here that here there might be a problem because we're initializing, creating and destroying classes all the time. So it's not very efficient. Also, now someone that wants to work only in the movement and not in the behavior, we will have problems because there's only one file with moving and behavior. So it's not very efficient for teamwork and to make very complex stuff, because you see that only creating the publishers and selecting the movement. So if the movement is flip, we have to set the joints values here, and if not, again, joints, and then we have to fill in all the variables that we send and publish. This is made every time that the callback is called. It works? Well, let's have a look. So let's execute this. Okay. So here we are. So you see basic stance movement. If I flip it around, whoop, there you go. So it worked. Yeah, fantastic. So where are the classes? Why do we need them? Well, as I said, one of the problems is that we only did this very simple 2 movements. What if we want to do complex movements? What if we want to access more stuff? What if we want to control the joints? And blah, blah, blah. And what if we want it to be part of a big project and someone has to take care of the movements and another person has to take care of the behavior? All this, very tedious, and it's not practical. So we generate classes. So we do one class for the behavior, and then we create a class called ROSJoint. That way we have a teammate that works on the movements and another one that works on the behavior and the IMU data extraction. Yeah. So basically we just generated this class and this class, which is the main one. And we have created this name main, start IMU behavior. And here we initialize the node and we start the behavior, which is this class. And here with the init, we initialize this ROSJoint that will be in charge of moving the robot. I don't know what it does for the moment, just that it does it. And then we start this subscriber. And as you can see, we retain this spin. So we depend on this callback to do everything. Yeah, so it's essentially the same thing, but instead of calling that method that we had here, we are calling this execute movement that it's inside this class. That way we don't have to initialize these subscribers all the time, but we initialize it only when we create this class. Because if we go to this class, you see that in the init function, it initializes all the publishers. So good, that's good, right? And also it allows us to make a very complex, you see that we initialize also joint states, and we when we execute a movement, we validate that the joints got to that position, and we have loads of movements and this kind of stuff, okay? That's great. But we're going to see there's a drawback doing it like this, which is the following. Let's execute number 3. Okay. Now let's turn it around. Okay. You see that it's not detecting correctly. It goes really slow. So something happened there. And that's what I want to talk about, is that classes are good, are the best way of doing it, but you have to create them and use them wisely. Otherwise, you're better doing it like this, with no classes, anything. Why happens this? It's all revolves around this get emu data. So this get emu data has to wait for the execute movement. So we won't have new IMU data until this movement finishes. So this generates this sluggish way of working, of behavior that it's not responsive because we're waiting and we don't have the latest IMU data to make a decision upon. Yeah. So how do we solve this? Well, finally, number 4, which is we need a class for the movement and we need a class for the IMU data. That way, the IMU data will be updated all the time because it's independent of the joint mover. It doesn't have anything to do with the movement. So let's have a look. So this Gurdi IMU data processor, what it does is starts a subscriber that I've added this check IMU data so that we are sure that we have the topic running and we get the data. That way, when we start the simulation, when we start the script, we are sure that we have IMU data. Otherwise, sometimes with topics, there are strange things because they're not connected yet and I have to make a decision. So it's a real mess. But this classes gives us this functionality that I can do this much more complex and robust without making this really dodgy and messy. Yeah. So once we have that, once we detect that the topic is ready, we process the data, which we have it around here, that it's exactly the same as we did it in the first exercise, in the first example here, it's exactly the same. Yeah. Just that now we are storing this value detected upside down, and we have a function that when you call it, you get this data. Yeah. But this is being executed all the time, you see? Once you have initialized here, this class, you have the subscriber here, and it will be calling all the time this callback each time that it gets a new data. This means that it will be updated all the time. Good. And then we have the join mover that we haven't touched. And as you can see, you see that here it was messy because we were working with IMU data and behavior, which it's not related. So this way, we only work on the behavior. So we're not touching anything about IMUs. We just call this class is upside down, yes or no. I don't care how do you do it, just do it. And then we say, okay, this is a behavior because if it's upside down, then flip. If not, basic stance. Yeah? And execute the movement. But the IMU is not waiting for the movement execution. Yeah? So let's have a look. Number 4. Okay. Same example. We roll it upside down, and now perfect. You see that it wasn't sluggish at all. There you go. And it's super robust. Yeah, because you see that it retries each time, which that's really nice. That's really, really nice. Why does it retry? Just because we could generate better movements, and repetitive movements are more complex than with the first examples, with this one, for example. Because here, the flip movement was just one position, while here, we're calling this basic stance, which is defined here, and we have basic stance, which is this stance that it's here now. But the flip, you see that it's a sequence. So it's this movement and this movement. This makes that push that it does when you flip it. You see that? Opens and closes until it gets to the correct position. Yeah, so through classes, we could make movements very complex or much more complex than we could have done here. Just because it would be really messy, because we would have to do a sequence of movements and this kind of stuff. So, and yeah, that's quite it. So in essence, classes are good if you want to do a medium to more complex projects, and you saw that it got complex really fast. So normally when you want to do something slightly complex in ROS, you'll need classes. And my recommendation is that you do everything in classes, not like this one, which has had something in classes, something not, but everything divided in concepts. That way it will go much faster and you're doing everything in parallel. And that's it for today. I hope you liked this video format. If you did, hit that like button and subscribe if you haven't subscribed yet. I don't know what you're doing with your life. And in the next program, we'll try to answer another question and justify why do you need blah, blah, blah. So leave it in the comments if you want us to answer and explain why do you need certain thing in ROS. And that's it. Until then, keep building. Keep building.